Good day, viewers. The topic before us today is electronic configuration. Electronic configuration. I was taking SS3 class sometime back, second term, a topic, hybridization. Hybridization. There is no how we can take that topic without discussing about electronic configuration. Along the line, I find out that we were having some difficulties with the electronic configuration. So I thought of it that we should take or discuss more about electronic configuration. Configuration is talking about how electrons are being arranged in an orbital. How an electron is being arranged in an orbital. So if you're talking about these orbitals, we have four major types of orbitals. We have the S, the P, D, and F. The S is known as the sharp, P is known as the principal, the D is known as the diffuse, and the F is known as the fundamental. So the S is known as the sharp, P principal, D diffuse, and the F fundamental. Now that we've known this, the next thing to know is that each of these orbitals, let's talk about the degenerate orbitals, or also known as the suborbitals, and also to know the amounts, the numbers of electrons each of these orbitals and suborbitals can take. Let's check out. So up here we have orbitals, here we have the suborbitals or degenerate orbitals, and here we have maximum numbers of electrons in each of these orbitals. Firstly, let's start with the S. The S orbital, we have the P, we have the D, and we have the F orbital. This S orbital is having just zero degenerate orbital. What do you mean by that? That is, the orbital cannot be further divided to some suborbital. When we say suborbital, that is orbitals inside the normal orbital. So which means that we can only have just one. That is, you cannot divide it further. So we can only have one generator. And the maximum of electron we are having there is just 2. Because in each of the degenerates, we can only have just 2 electrons in each of them. So for the P orbital, we have just 3 degenerate orbitals. Then from here, we have just 5 degenerate orbitals. Here we have 7 of them. Which means that if we multiply this one by 2, we have 6 maximum number of electrons in that orbital of P. If we multiply this one by 2, we have 10 maximum, and here we have 14. What do you mean by this degenerate? If you look at this, the S is having this, the P is having 3 of this. If you look at this, 1, 2, 3. But this one, when we have this orbital here, we could not divide it further. We can only have this. Then this one, we have 5 of it. We have 5. 1, 2, 3, 4, 5. That is, we can have just this 1, 2, 1, 2, 1, 2, 1, 2, and this. Make it 10. If you count this, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is, in each of the generates, we cannot take more than 2. And lastly, the orbital of F. You cannot take more than 7 to be the degenerate orbital. So at the end of the day, we are going to be having 14 electrons. So likewise, if you look at the P orbital 2, we have this and this. This shows the numbers of electrons we can have in each of the orbitals. Now that we've known this, that this is what we're going to be having, let's move to the next one. So we are going to be talking about the energy levels now. The energy levels. We have different energy levels. Let's start with the first one. It is in form of a sequence. Let's look at it. It starts this way, then followed by 2s, 2p. We have 3s, 3p, 3d. We have 4s, 4p, 4d, 4f. We have 5s, 5p, 5d, and 5f. We have 6x, we have 6p, we have 6d, we have 6f. We have 7x, 7p, 7d, 7f. Now you will see this way it is moving. The first one we have 1s, the next one we have 2s, followed by the 2p, that is s, p, d, f. We use s and p. Then we have 3s, 3p, and 3d. Now our 4s, 4p, 4d, 4f. You see that we stop at f. Consider that everything will be stopping at f, the more you have it. So from there, it moves this way. So if you look at it very well, you will see the way we have it. So what we have to have here is that it is moving in this order of arrow. That is descending order like this. That we are going to be having. We are going to start from the first area, and the first one here we have 1s. That's the first energy level that we have. We have 1s, which is the least of all, followed by 2s. After we finish this one, we move to the next arrow. After we move from that next arrow, we move to the next arrow. And we start from this up to down. We have 2p, followed by 3s. Followed by, after we finish that arrow, we move to the next one, followed by 3p. Followed by 4s. Followed by 3d. Followed by 4p, and in that format, that's how you'll be having it till wherever you feel like stopping. So that is what you are having there. So now that we know this, you have to be careful. Ensure you follow that order. This is the lower energy level, followed by this, followed by this, in the increasing order of the energy level. That is what we are having there. Now that we know this, we have to move to the next one. The next one is the rules guiding the filling of atomic orbitals. the rules guiding the filling of atomic orbitals. We have 3 of them. The first one, we have the Ohm's rule. The second one, we have the Aufbau's principle. The third one, we have the Pauli exclusion principle. We have the Ohm's rule, the Aufbau's principle, and we have the Pauli's exclusion principle. And what does these 3 rules state? The first one, the Ohm's rule, states that in filling of atomic orbitals, you have to fill singly first before pairing occurs. The Aufbau's principle states that you have to fill the lower energy level first, that is, the energy levels we had initially. So we have to fill it not really from the lower energy first, from 1s to 2s to 2p and so on. Then the Pauli exclusion principle is telling us that it is not possible for us to have 2 same quantum number. How we explain that? Recently, we can talk about the spin, which I will show you by the time we are filling the atomic orbitals. Now let's go in details to the electronic configuration now. Now discussing more about the electronic configuration now, in details. We have to quickly recall that we know the first 20 elements from hydrogen, helium, till calcium, which is the 20th element. And we have to know some things. Let's start from hydrogen. Having the atomic number of 1. Generally, for now, we are going to be discussing about a neutral element, a neutral atom. So, without any charge. So, the first one we are talking about, we having just 1 electron. Don't forget, the first energy level is 1s. And s cannot take more than 2 electrons when we are discussing about the energy levels in that tabular form before. So, which means that our s, the first one, 1s1, because we have just 1 numbers of electrons. Let's quickly recall that for a neutral atom, the numbers of electrons that we have for an atom is equivalent to the atomic number, which is also the same as the proton number, the numbers of protons. So, which means that if we have the atomic number to be 1, definitely for a neutral atom, the atomic and the numbers of electrons will be 1. Helium, this is having atomic number of 2. We will be having 2 electrons, that is 1s2. Lithium, having atomic number of 3. We have 1s2 and 2s1. This is because s orbital cannot take more than 2. So the remaining one that we are having left here will be split to the next, will be pushed to the next energy level, which is 2s2, as shown before. So the next one, which is beryllium, which is 4, that will be 1s2, 2s2. Because we are having 4 as the atomic number, which is also equivalent to 4 electrons in a neutral atom of beryllium. The next one is boron, atomic number of 5, that is 1s2, 2s2. Don't forget, s orbital cannot take more than 2 electrons. Then the next one, we're going to be having 2p1, that is 2 plus 2 plus 1, that is 5. We give you this. 2 plus 2 will give us 4. 2 plus 1 will give us 3. So just that this one is 2, 2, 1 and 1. Then the next one, which is carbon, atomic number of 6. That is 1s2, 2s2, and 2p2. So that's how it will go. Till we get to the 10th element, which is the neon, and that is number 10, and that is 1s2, 2s2, 2p6. As this will still retain this, and you are going to be this number of electrons here in these orbitals here will increase to this 10 if you move it in this order, if you complete this. When you get to number 11, the 11th element, which is sodium, that is 1s2, 2s2, 2p6, 2p6, and p orbital cannot take more than 6. We have to move to the next degenerate orbital. When we stop at 2p6, we move to 3s. That is 3s1. That's what we are having there. And that is how it will go. Magnesium, which is having the atomic number of 12, has numbers of electrons of 12 for a neutral atom. And that will give you 1s2, 2s2, 2p6, and 3s2. So let's try that of aluminium to the next one. For aluminium now, it's having atomic number of 13. That is 1s2, 2s2, 2p6, 3s2, and 3p1. Because when you add this up, 2 plus 2 plus 6 plus 2, that will give you 12. Then it's the remaining one. That's the one we move to the next degenerate orbital, which is 3p. And that is how it will go on. And it will fill up to the 18th element, which is the argon. And argon is the 18th element, and the configuration is 1s2, 2s2, 2p6, 3s2, 3p6. Then the next one, after argon, we have the potassium, which is the number 19. That is 1s2, 2s2, 2p6, 3s2, 3p6, and we now have 4s1, which is the next degenerate orbital. The next energy level. So now that we have that, the last one, which is the 20th element, is calcium. That is 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. That is how it goes on. Till we move to the next element, element you are having, anyone you want. But the most important thing is that you must master from the first element to the 20th element for us to talk more about our hybridization, which you will learn more in the next class. So I would love that you subscribe, you like, you comment, and you also share on this link and this YouTube channel to learn more about chemistry. I will teach you, I will explain, I will let you know. Any other thing you have to know, ensure you chat me up or you DM me on my WhatsApp number that's on the screen here. You will learn more. In our next class, we will be learning more about hybridization. Hybridization is just talking about the mixing of atomic orbitals, which you would have learned from SS3, and you also learn more about in your institution in your probably your 100 level days. Probably your 100 level days in the institution. I wish you the best. Thank you.